So here we have the NumPy arrays which come to the rescue, and these are basically used for data storage because they have a fixed type. So rather than lists, we cannot assign different data types to a single NumPy array. All of the values in a particular NumPy array will have one data type, and they are efficient and they are less flexible as compared to lists. Okay, the syntax for creating NumPy arrays. So we have imported NumPy as NP. Now we're going to use NP dot different number of functions, and we're going to access the number different functions NumPy is going to provide us. That's why we call it the interface, because we can call numerous functions from NumPy and we can use them to do our jobs. Okay, so the first thing we should learn is that in order to create a NumPy array, so for that we need to call the np.array. We would initialize it with integers, and this will be the integer array. And this is quite simple. We're just going to call array as a function of NumPy to create a NumPy array. And if we want to visualize every command, we're going to see that after doing this, we have a stack. It doesn't really matter for the time being, because we're going to discuss about the dimensions and shapes of every NumPy array in order to get a better sense of how they are oriented. But for now, let's just think of them as a sequence of numbers. It doesn't matter if they're stacked. It doesn't matter if they're stacked vertically or horizontally. For the time being, let's just imagine them as a sequence or list of numbers which are just associated together. We have discussed that NumPy arrays have a fixed type. The thing about NumPy arrays is that unlike lists, we cannot have different types of data types in the same array. If we try to do something like that, NumPy array will automatically upcast all the remaining integers to floats. So let's look at this. If we want to initialize an NumPy array with the first value as 3.14 and the rest of them as 423, so you can see that 3 values are integers and 1 is float, which is illegal in NumPy. However, it does not give us any error on this. What it's going to do is it's going to automatically convert all the integers to floats. It's quite smart because if you look at it, it won't really affect the logic behind it. It won't really affect the data, and it will also follow the rules. So if I convert the integers into floats, I will just have to append a 0.0 to every integer. So it is still the same value, and it won't affect the outcome in any other way. Now this way we have a fixed type. We are going to reduce memory. We don't have redundant information, and we also are following the efficiency protocol of NumPy. So if we have seen that the NumPy array can automatically determine what would be the data type of the array, but it also gives us the power to explicitly set the data type. So if I have a NumPy array and I want the values to be floats, I'm just going to add another argument, another parameter, which is the d type, and I'm going to equate it to float 32 in single quotes. So this is a syntax, and we can use different ways to set the data types of arrays. Like float 32, we have integers as well, as we will see soon. So we have seen single arrays. Now let's imagine if we want to discuss 2D arrays. Before we jump into the concept of 2D arrays using NumPy, I want to make sure that everyone understands what 2D arrays are. 2D arrays are numbers which have rows and columns. So we have stacked numbers in such a way that they have a particular orientation. Each line of the numbers is a row, and the vertical orientation of them are columns. So it's just like a matrix which has rows and columns. So a 2D array has 2 dimensions. We can stack numbers in a sequence and above each other as well. So let's see the syntax for initializing 2D NumPy arrays. It's quite simple, but you need to pay close attention to the square brackets we are using here. So we have used 2 square brackets, one for the outermost square bracket and for the entire matrix, and individual one around every row. So the inner square brackets indicate and tell NumPy that these are rows, and the comma separating these inner square brackets tell us that this is a different row. The square, you can say that the inner square bracket would tell us that these values belong to one row, and the second inner square bracket tells us that these values belong to the second row. And we can use the d type to explicitly set the data type of it as well. And if you want to have more values like 3 rows and 3 columns, we can just keep on adding square brackets with a sequence of numbers. But it's important to understand this syntax, and it's important to learn it, because sometimes we mess it up and it gives us an error, and it takes us quite some time to figure it out. This is the you can say a cheat sheet for NumPy data types. As I said earlier, we can use the dtype argument to set different types of data types, and these are a list of data types. We have integers 16-bit, we have integer 32-bit, 64-bit. Depending on the type of problem, we will use the associated data type for it. So we have seen ways to create a NumPy array and initialize it with values of our choice. But there are certain default functions which give us the power to initialize values which are quite different. So let's look at these different ways to initialize NumPy arrays. So imagine you need to create an array of zeros. And so you're thinking, why do I need an array of zeros? You need it mostly whenever you're dealing with images in computer vision. You need to pad images and stuff like that. And you also need a list of zeros for other things as well. So it gives us the power to quickly generate an array of zeros by using only a single line of code. So we have the syntax for that is np.zeros, and the number inside it tells us the number of zeros we want in the array. So it's quite simple. We have the number of zeros we want and the data type to initialize it, and that's about it for the number of zeros. And the same case goes with the number of ones, np1s. If we want a list of ones, we are going to use np1s and do the same thing. And okay, so there's another important thing over here we need to understand. The thing is that if we need a 2D array, we're going to initialize the number of rows and columns by using inner square brackets and separating those numbers by comma. So this is the syntax for creating a 2D array of ones, and we're going to use it to create an identity matrix, which will also be used for a number of reasons. For example, if you want to create a filter in computer vision, you can use it for that purpose as well. Also, if you want to create an array of random numbers. Random numbers are basically used whenever you're initializing convolutional neural networks with convolutional filters, which are often initialized. The weights in those filters are often initialized by random values. So this is quite a handy function for that. So you can see that NumPy is made basically for data science purposes. These are the associated functions which only data scientists use in dealing with data preparation and data extraction, data initialization, and stuff like that. So NumPy is the most powerful library ever created.